So good evening, kids. Today we will discuss your module 5 in general chemistry, which is your ionic charges and your ionic compounds. So first, in your ionic charges, kids, look at this table 2.3. These are your formulas, your ionic charges, and names of some of your common na ions. So your positive ions are known. Review natin. Ang positive ions ninyo are known as your cations. And your negative ions are known as your anions. So the formula for your these are the common nga formulas nga ara nga itakol natin. Common lang sila. Don't worry, hindi ko mapadalong sa inyo for chemistry. As you will only need the common ones for your forensic chemistry and other types of chemistry. Amo gid sila usually ang kagwa gid. So first, you have your sodium. Ang sodium naton has a charge of 1 plus. Hindi sa plus 1 have 1 plus isa if we are talking about the charges. If it is an cation, usually 1 plus, 2 plus na siya, hindi sa 1 minus. Usually kay positive ions. Gani, basta cations, expect mo ang ilang charge is always positive. Basta gani cations, there is no negative. Always lang na sila positive ions. So your Na plus nga formula stands for your sodium. Sodium sa the same is for your K plus, which is your potassium. Your NH4 plus is your ammonium, in which it has a charge of a 1 plus positively charged ion siya. And you have your silver, which ang formula is Ag plus and its charge is 1 plus. Next, we have your 2 plus charges. These are just our common compounds. Next, we have your magnesium, your calcium, your zinc, and your copper 1. Kita niyo di wala siya sa 1 sa babaw. Copper 2, which has 2 plus na charge. And you have your iron 2, which has a 2 plus or 2 positive charge. And you have your iron 3 and your aluminum. Ang aluminum ta is always a constant of 3 plus. And you have your iron 3. Kay iron 3 siya, it has a positively charged nga tatlo sa imo. And next, we have your anions. Ang anions naman natin are the opposite of your cations in that they are negative ions. Ang anions natin, again, are negative ions. Ang negative natin so shows a negative charge. Our one negative nga mga charges are as follows. You have your fluorides, chlorides, bromides, hydroxides, acetates, and their nitrate. And this is how you write your fluorides until your nitrites through their formulas. Ang fluoride natin is an F negative. Ang aton nga chloride is a Cl negative. Ang inyong bromide, Br negative. And your OH, tapos ang siya aton hydroxide, CH3COO negative is your acetate. NO3 is your nitrate. So on and so forth. Next, we have your oxide, sulfide, sulfate, sulfite, and carbonate. These are your two negative charges naman na anions. And you have your phosphate, which is a negative 3. So, kids, tandaan nyo lang di sa ila sa positive kag negative na to na ions, pero may dapat na una, kung magsulat ka mo sa may positive kag negative na charge, bala, pero may gidyan una si cation, ang positive charge before kay negative charge, okay? So, next, 2.4, names and formulas of some ionic compounds. During your study of chemistry, you will have many occasions to refer to compounds by their names. In this section, we shall see how a few compounds should be named. More comprehensive rules for naming compounds are presented at the appropriate places later in the text. Table 2.2 includes examples of names for a few common molecular compounds. You should learn that short list before proceeding much further in this textbook. So we shall name many more molecular compounds as we encounter them in later chapters. So arit kids ang inyong mga tables and how they are used. So, diri lang mo base kay diri sila ang ato na common nga ions kagari sila ang table. So your ionic compounds clockwise from the top. For example, ang salt naton contains your sodium chloride. Sodium, muna siya. Ang chloride mo ini. Sodium chloride naton is also known as your NaCl. So, have you noticed nga ang NaCl, ang sodium chloride, is a 1 plus? And your chloride is a 1 minus. So, dapat, check nyo diyan ay kids. Si sodium naton may positive na charge, tapos si chloride naton may negative na charge. Pero may dapat kids tandaan yung si positive charge, magpangalan ka bo, na una kaysa kay negative na charge. So, si sodium, una gina-permi before kay chloride. Again, una permi si positive ion kaysa kay negative ion. Ang muna pagpangalan tayo, hindi pwede chloride sodium. Dapat sodium, chloride kay una si sodium because it has a positive 1 or 1 plus na charge. And si chloride naton has a negative 1 na charge. 1 negative na siya. So, your NaCl, your sodium chloride, ang muna siya ang iya fluoride, chloride, ang muna siya ang iyang formula. It has a 1 plus and 1 negative charge. Dapat magpangalan ka mo, kids, you make sure nga neutral na siya. So, kung ang 1 plus natin, ang 1 minus natin, i-add natin siya, kids, or isolve it has a neutral charge na. Ang neutral nga charge, ang muna siya dapat ang kaon natin para maka-combine tas ang inyong compounds. Okay? So, further explanation down below. Wait lang ha. The names of some common ions appear in your table 2.3, which is aring table 2.3 naton. Diri ka mo tan-aw karon ha kung di na inyo na charges. You will need to know the names and formulas of these frequently encountered ions. They can be used to write your formulas and names of many ionic compounds. So we write the formulas of an ionic compound by adjusting the relative number of positive and negative ions so that their total charges cancel out. Again, dapat maging zero. For example, again, ang inyong sodium fluoride. Ang sodium fluoride natin, kung isulat na siya sa formula, NaCl. Ang sodium natin, kids, which is Na, may sa positive 1 nga charge or 1 plus. And ang ato na Cl, which is your chloride, has a 1 negative nga charge. So, kung i-add ta ni sila, kids, nga dua, we will have a 0 net charge. So, kay 0 na siya, kids. Amo na siya dahil ang inyong ionic compound. Okay, again, may ara sila. Dapat, dasan ko, we write the formula of an ionic compound. Magsulat ako na sa inyong ionic compound. You adjust the relative numbers of a positive and negative ion so that their total charges cancel out or they kids, dapat maging sila, 0. So again, kids, dapat maging 0 sila. Gina-adjust sa atong compounds in order for us to get a 0 nga charge. The name of an ionic compound is formed by giving the names of the ions with the positive ion first. Permi na kauna, si positive charge kaysa kay negative. So, permi una si cation ions kaysa kay anions. Kaya again, your cation ions are your positively charged ions and your anions are your negatively charged ions. Okay? So, we have an example on how we name the formulas for each ionic compound. So, ari siya kids at an example. I will show you down below. So, first and foremost, kids, how do you name your ionic compounds according to your formulas and how do you write them? So, you write the formulas for the following ionic compounds. When I am giving you a sodium fluoride, calcium fluoride, or your iron 2 sulfate and zinc sulfate, you will write as follows. So, your plan first. In each case, we identify the chemical formulas of the ions from your table 2.3. Ang sa aton page 1 pa lang, table 2.3 natin. These ions must be present in the simplest whole number ratio that gives the compound no net charge. Again, wala siya sang net charge, meaning maging 0 na siya. So, your keyword, dapat maging 0 ang aton nga compounds in order for you to write your ionic compound. So, recalling that, the formulas and the names of your ionic compounds are written by giving the positively charged ions first, meaning permigid na kauna sulat si positively charged nga ions natin or our cation ions kaysa kay anions natin or our negatively charged ions. So again, permigid na kauna ang positively charged kaysa kay negatively charged. Permigid niya siya na kauna kaysa sa iya kay negative nga charged nga ions or our anions. So first, kids, answeran natin si sodium fluoride. So how do you write your sodium fluoride, kids? Ang sodium natin, let us look at your table 2.3 si sodium natin. Ang formula niya is Na+. Ang charge niya 1 plus kay sodium. And your fluoride, paano to sa sulaton, kids? Letter F ko ng formula ni fluoride. And it has a net charge of 1 negative. 1 negative si fluoride. So, kay nakita ta na nga si sodium, Na plus pagsulat na siya. Tapos ang iya charge 1 plus. Ang si fluoride naman, kids, ang iya nga pagsulat is F negative. Ang iya charge din is 1 negative. Therefore, kids, isulat nga si sodium fluoride as per its formula. Ang formula, kids, si sodium fluoride nyo, Na plus. 1 plus na siya, diba? Si sodium naton is Na1 plus and your fluoride is a 1 negative na charge. So, kids, 1 minus 1 is equals to 0. Therefore, we cancel out the positive and negative charge and we answer. Ang final answer natin on how we write our sodium fluoride will now be NaF. So, that is how you write your ionic compounds. So, this is your letter A, your sodium fluoride niya. Letter A na siya. Next, you have your letter B, calcium fluoride na naman. So, first basahon ko na yung letter A kung paano kang siya ginsolve. So, the formula for your sodium ion is Na. Kamunin siya kinsa nga itong sodium. Na, ari siya. And the formula for your fluoride is F negative or F1 negative ni siya. Kay kids, kay 1 lang siya, pwede ito sa masulat positive lang or negative because it is understood nga ang aton positive kag negative represents 1 kung wala siya sa number 2 and above. Because kagintan, ako ni dahil kaginkuha from our table 2.3, okay? Dirito na siya ginkuha sa table 2.3. Para ang table 2.3. Next. Because the charges on these two ions are equal in magnitude, again, equal sila. Ang isa 1 plus, ang isa 1 negative. The ions are equal in magnitude. The ions must be present in equal numbers. So, equal ang 1 plus kag 1 negative? Yes, of course. 1:1 na niya ratio? Yes. Therefore, maging 0 siya and you now thus have to write the formula for sodium fluoride which is NaF. Kaya na cancel out na ang duwa. Okay? Next, we have your letter B. Anong ating letter B, kids? It is our calcium fluoride. So, how do we write your calcium fluoride? So, the formula for our calcium ion is your Ca2 plus. Ca2 plus. And the formula for your fluoride ion is negative 1 negative. So, ang 1 negative nga ni, isulat na di anay. Now, each positive ion of your calcium is 2 plus. It provides twice as much charge as each negative ion sang aton nga fluoride. So, equal sila? Hindi. Of course not. They are not equal. So, there must be twice as many fluoride ions as there are calcium ions. So, meaning, mas kadwa nga dapat nga fluoride ang ara kaysa kay calcium naton ion. In order for the charge to equalize. Again, dapat equalize gid ang charge because again, ano gani ang bawgi na sa inyo kids? Dapat magsulat kung sang ionic compounds ninyo, wala ka mo bilin nga net charge. Araon, no net charge must remain. This means that the ratio of your calcium fluoride is 1:2. Ang isa ka calcium naton nga ion, kada isa naton ka calcium nga ion, may arat ta dapat duwa nga fluoride para maging 1:2 or para magdula ang net charge siya maging 0. So, therefore, maging amo na ni siya kids. So, Ca F2. Amo na ni siya aton nga final answer. Why is that? Because, kids nga man nag-CF2 ni. Check niyo diha. If I have one calcium ion, pila na yung iyang net charge? 2 plus, di ba? So, para mag-balance ni, pila ka fluoride kilangnan ko? 2 ka fluoride. So, butang ko di, F1. Kag isa pagid ka F1. 1 negative di sa ha. So, 2 na kon ka F1. maging F2. Tama? Equals to 2 negative. So, 2 negative plus 2 negative plus, hindi, 2 positive plus 2 negative is equals to 2 minus 2 na lang. Para intindihan nyo. 2 minus 2 is equals to 0. Galing pila pabilin ko nga fluoride? 2. Therefore, my final answer will be Ca. Why na ko charge? Diba? Kaya nag-0 na sila, nag-cancel out na. 2 plus ko, pag akong 2 ka, negative 1. Kaya 2 akong fluoride nga bilin, Ca, 2 ni ka fluoride. Check nyo kids, 2 ka fluoride. Ca, 2. Muna na siya dahil ang final answer natin sa letter B. Kaya again, dapat kung magsulat kamo sa ionic compounds nyo, balance sila and no net charge will remain. Okay? Letter C naman natin, you have your iron. Your iron 2 ion which is Fe2+. Kaya again, ang number 2 na represents its number of charges. Okay? Iron 2. Ang number 2 nga na sa ion sang iron 2, diri sa letter C natin represents its number of charges. Remember niyo pa sa midterms kung paano kung pangalan sang inyong metallic compounds, di ba? Muna. And the sulfate ion. Sulfate ion is written as SO4 2 negative, as in part A, the equal magnitudes of your positive and negative charges tells us that the ion must be present in equals number or in a 1:1 ratio. So kids, simple man ni siya gyapon ang aton na letter C. Ang letter C ta mo niyo. Letter C niya. Letter B niya kagina. So ang letter C naton, first we should write your iron nga ion. Iron 2 ni siya, iron 2. Fe 2+. Next, we should write your sulfate nga ion. Ang sulfate natin nga ion, kids, is written as SO4. Pila ang sulfate ion natin? Nga charge 2 negative. So, kids, kita nyo ang pattern. Equal ang aton 2 plus kag 2 negative. Yes, they are equal. So, kung i-plus na ni siya, you will have a net charge of 0. So, cancel out ang 2 ka 2. And your final answer will be Fe SO4. Manage din ang final answer niyo sa letter C niyo. And lastly, your letter D, the zinc ion or your zinc ion is written as Zn2. Letter D na ni siya. Wait, so the letter D. Zn2. And the phosphate ion is written as PO4 3 negative. PO4 3 negative. Now, it will take 3 zinc ions to account for as much as 6 positive nga charge ang aton nga phosphate nga ion as would be present in 2 phosphate ions. 6 negative in total. Kaya again, tanawan nyo bala, kids? 2 negative, 2 positive ni ang aton zinc. And your PO4 has a 3 negative nga charge. So, para ma-balance out mo ni sila, kids, ano dapat ang aton obrahon? Kids, dapat patason ta sila. So, ano ang ila common nga ground para mag-ano sila? So, 2 times 3 is equals to 6, tama? And 3 times 2 is equals to 6. So, you now have Zn 3. Kaya again, 2 times 3 is equal to a 6 positive charge. 6 positive na charge. And our phosphate ion, ano ang aton i-times sa iya para mag 6 man sa para pata sa di kay zinc? 3 na siya kay tatlo ka zinc ion para mag 6, di ba? Mag 6 ang iya charge. Tatlo ka zinc ion para mag 6 siya. Plus, hindi, phosphate ng gali. Phosphate ay PO4. Pila ka 3 ka, ano kids? Ka 3 negative nga ion para mag 6 negative siya total. PO4 natin eh. Para mag-shift sa, yung 3 natin i-times na sa 2. Therefore, i-parenthesis na ni siya. Kaya again, may ara ka di sang atomic weight sa dalom. 4 ni siya ka oxygen, di ba? Para hindi siya mag-multiply, butangan ta sa ang parenthesis. Umuna siya nag-ZN, PO4. Pila ka ion liwat ang ara siya. Ang sa 3 natin nga charge, para mag 6 negative siya total. 3 times 2 is equals to 6 negative. 3 times 2, ang 3 arikid. So, paanta siya sang 2 para maging 6 man siya. Patas kay zinc naton 2. Butang ko din si 2. So, patas na ang akon nga charge, hindi. Patas na. Therefore, cancel out this. And your final answer will be Zn. Cancel out na ng 2 ka 6. Kaya nagpatas na siya, meaning you have no net charge. Kaya nagpatas na siya, kids. Zn. 3. Open close parenthesis, your phosphate. PO4. Then this will be your final answer na. Dayon. So this is how you write your ionic formulas and compounds. So now that we know how you write your formulas in your ionic compounds, next we have the names for your ionic compounds. Paano ta sila pangalanan ang aton nga ionic compounds when we are given the formula. So name the following ionic compounds. You have your NH4, 2S. You have your CuNO3, 2. You have your zinc, Zn, Cl2. And you have your iron, Fe, CO3, 3. So how do you know that these are the formulas of each compound? Again, to know this, you need to have a periodic table of elements, which I will provide man sa inyo, or you need to look at table 2.3. So first, in naming ionic compounds, it is helpful to inspect the formula for atoms or group of atoms that we recognize as representing familiar ions. So letter A first, NH4 to S. The presence of your polyatomic groupings of your NH4 in the formula suggests the presence of your ammonium ion. Therefore, ang NH4 naton is also known as your ammonium. Ammonium nisa. Ammonium. There are 2 of these, each accounting for 1 in each charge. Kaya ang nakabutang di sa aton kids na letter A, NH4, 2. So, 2 ang aton nga NH4. Ang nakabutang daan to is NH4, 2. So, you have 2 molecules of ammonium. Next, to balance this, kay may 2 ta ka 1 plus nga charge, meaning 2 plus ni siya, the single naton nga S must account for 2 negative in charge or S2 negative. So we recognize the sulfide and thus the name of your compound. Kaya ang S naton 2 negative. Kaya ang 2 negative yun check natin sa table. Ang S naton is equals to 2 negative. Therefore, kay may 2 na ko ka ammonium ion, 2 plus na siya. Kaya ang isa ka ammonium ion is 1 plus. Kaya galing kay may 2 ta, 2. Therefore, equal na sila. Cancel out. And next, we have your final answer. And how do you read this? Ang ngalan sang NH4 ta is ammonium. And ngalan sang S natin is sulfide. Sulfide na yung aton S. NH4 2 S. Ang NH4S ni will now be read as NH4 is ammonium. Ang S natin is sulfide. Therefore, it is now known as your ammonium sulfide. So, this is how we name your ionic compounds. Letter B. The NO3 grouping naman sa aton nga formula tells us that the nitrate ion is NO3 negative is present. Two of these nitrate ions account for 2 times 1 negative is equals to 2 negative in negative charge. 2 times 1 is equals to 2 negative, right? Okay, 2 times 1 negative is 2 negative. To balance this, copper must account for 2 charges and be the copper 2 ion. So the name of your compound is now copper 2 nitrate. So first, paano na siya? Cu NO3. Close parenthesis. Why? Nga malimutan ta, open close parenthesis. Again, to separate your 2. Ang 2 nga ni is an equivalent of your copper. Kay nakabutang di copper 2. And your NO3, pwede na siya matans para mag-6. Again, para mag-6 aton nga oxygen. So your Cu2, your copper 2 has a 2 plus charge. And your NO3. Iron nitrate is a 2 charge lang gid siya. Again, alone your NO3 is a charge. Therefore, when all of this is done, makancel ni sila kay pata sila. There will now be a known net charge. Therefore, ang final answer natin sa aton nga problem in naming ionic compounds is this. You have your copper 2 and your nitrate, your copper 2 nitrate. Paano siya basahon? Again, you will read this as copper 2 nitrate. Copper 2, para siya copper 2 nitrate. Erase. Copper 2 nitrate. Next, the positive letter C naman natin, how do we read ZnCl2? This is read as, ang Zn is zinc, and ang Cl2 is your chloride. So next, the positive ion, letter C naman natin, the positive ion present in your zinc ion is Zn, kaya ang zinc natin, kids, 2 plus ang yan charge. And the negative ion is chloride. The name of the compound is now zinc chloride. 2 plus na siya, therefore, Zn. Aray, diretson ko na lang ha. And you have 1 negative na chloride, di ba? Ang Cl natin, therefore, will be Cl2. To balance this ara. O may ZnCl2 pa man din. Kaya again, ang isa natin ka-zinc has 2 plus na charge, kaya ang isa natin yung chloride, 1 negative lang. Therefore, para wala siya na charge, kailangan ka duwa ka chloride. Therefore, Cl2. Ang lang na siya. And how do you read this again? Ang Zn, zinc. Ang imo dahil nga Cl2 is known as your chloride. So the name of the compound is now zinc chloride. Letter D naman natin, iron 3 is also iron 3 carbonate is also written in this manner. Again, ang Fe3 plus natin is known as your iron. Iron 3 na siya, therefore it is 3 plus kay tatlo ang iyang charge. Iron 3 is known sa table 2.3 naton nga may charge nga 3 plus. So iron 3 has 3 charges, okay? Of your cation. Cation again is a positively charged ion. Next, you have your carbonate. Your carbonate is only of 2 charges, CO3 open close parenthesis niya, 2 negative. 2 negative na yung iya equals. Para mabalance na ni again, how do you balance this? Patason ta ang iya nga charge. So how do we So how do we balance this out? Again, ngita taas ang pidi nila nga times nga duwa nga pinakanubo. So again, anong pinakanubo nga na? Anong pidi ta nga multiply sa 3 kag sa 2 nga makakuha tas ang pinakanubo nga number? Of course, pwede sa ma-multiply in order for them to reach a number of 6. Tama? Therefore, duwata ka iron, Fe2 has now a charge of 6 plus. Again, how do you read this? Iron. And next. CO3 naton, kids. Has a charge of 2 plus. CO3, diba? In order for it to have a 6 negative charge, pila i-times ta kay 2. 2 times 3 is equals 6, diba? Therefore, 3 ang ibutang mo di. Therefore, you have 3 carbonate ions present. Para maka-6 negative ka. Cancel this out and you will have your final answer of Fe 2 open close parenthesis of CO3 3. And how do you read this as? It is read as iron 3 carbonate. Iron 3 carbonate. So now that we have discussed how you name your ionic compounds and how you write their formulas, we now proceed to your atomic weight. Your atomic weight, kids, is as the chemists of the 18th and 19th centuries painstakingly sought information about the composition of compounds and tried to systematize their knowledge, it became apparent that each element has a characteristic mass relative to every other element. Although these early scientists did not have experimental means to measure the mass of each kind of atom, they succeeded in defining a relative scale of atomic masses. These are known as your atomic weights. As early observation was that carbon and hydrogen have relative atomic masses, also traditionally called your atomic weights. So, kids ninyo nga atomic weights. Ang atong carbon and hydrogen have relative kuno nga atomic masses. So, ang atomic masses na, ano natawag sila? These are known as your atomic weights or ang kabugaton niya because mass is equals to your weight. They are of approximately 12 and 1 respectively. So, thousands of experiments on the composition of compounds have resulted in the establishment of a scale of relative atomic weight based on your AMU. O anong aton AMU? Kids, it is your atomic mass unit, which is defined exactly as your 1/12 of the mass of an atom of a particular kind of atom called our carbon-12. Again, ang carbon-12 naton, amo na siya ang aton basihan for your AMU. So, on this scale of atomic weight, ang aton nga hydrogen, kids, if you base it on our AMU, it has an atomic mass unit of 1.007994. And that of sodium is 22.989768 MU. And that of magnesium is of 24.3050 atomic mass units. So this tells us that Na atoms have nearly 23 times of the mass of our hydrogen atoms. Ang Na is again sodium atoms. Ang H naton is hydrogen nga atom. So, tanawang niya kabugaton times 23. Ang kabugaton ni sodium kaysa kay hydrogen, and your magnesium atoms are about 24 times heavier than your hydrogen atom. So, when you need the values of your atomic weight, you consult your periodic table or the alphabetical listing of your elements as they will show the atomic weights in your atomic mass units of each element from each compound, both found on facing pages of your inside cover or in simple terms, kids, ihatag ko na yung periodic table sa inyo. Ay, ara naman siya sa atomic mass units nyo and your atomic weights. So, that is your atomic weights, kids. Gamiton ta ang inyong atomic weights and your atomic mass units in solving different kinds of problems along the way. So, hultan lang kay may solving ta gamit ni. So, next we have the mole. The mole, kids, even the smallest bit of matter that can be handled reliably contains an enormous number of atoms. So we must deal with large number of atoms in any real situation, and some units for conveniently describing a large number of atoms is desirable. So it's ang ginagamit natin to describe a large number of atoms. The idea of using a unit to describe a particular number of amount of objects has been around for a long time. So you are already familiar with the dozen. Ang dozen, kids, is 12 times and the gross is 144 times, di ba? Common siyang ginagamit. Am I right? Na mga words ang dozen, ang gross, so on and so forth. So kids, ano ginagamit natin to measure your number of atoms? It is our moles. So the SI unit for the amount of mole is abbreviated into moles. So your moles, kids, for example, kung ang meter naton, ang abbreviation is letter M na gamay, your moles na naman, kids, is abbreviated into mole, M-O-L. Mole na siya, abbreviation sang atom na moles. Your mole is abbreviated into a mole. It is defined as the amount. Ari, kids, sandaan nyo, giti magwaan sa aton exam, ha? Ari, tip ko na sa inyo. It is defined as the amount of substance that contains as many entities, atoms, molecules, or other particles as there are atoms in exactly 0.12 kilograms of pure carbon 12 atoms. Kaya again, ang moles naton are based on your carbon 12. O muna, it is exactly 0.012 kilograms of pure carbon atoms. Many experiments have refined the number, and the currently accepted value or ang constant value sang 1 mole naton is 6.0221367 times 10 raised to the power of 23 particles. So, muna siya, kids, ang constant. And we shorten this, alam mo na lang na ginagamit na, kids, ang 1 mole natin is therefore equivalent to 6.022 niya times 10 raised to 23. Alam mo na siya, usually, kids, ang ginagamit natin for our chemistry. So this number is often rounded off to 6.022 times 10 raised to the power of 23. So kids, kung galibugulo nyo, amo ni siya, kids, ang inatawag natin nga Avogadro's number in honor of Amedeo Avogadro. Amedeo Avogadro, whose contribution to chemistry are discussed later according to its definition. Kaya again, kids, ang nag-discover ni sa aton nga 6.010 times 10 raised to the power of 23, kids. Ang muna siya, kids, so sino nag-discover ni? It is Amedeo Avogadro. According to its definition, the mole unit refers to a fixed number of items and the identities of which must be specified. Just as we speak of a dozens of eggs or pair of aces, we refer to a mole of atoms or a mole of molecules. So according to its definition, the mole unit refers to a fixed number of items, identities of which must be specified, so meaning given. Again, as we speak of dozens of eggs or pair of eggs, we refer to a mole of atoms or a mole of molecule as a mole of ions, electrons, or other particles. We could even think that a mole of eggs, or although the size of the required carton staggers the imagination. Helium exists as a discrete He atom. So 1 mole of your helium consists of, again, kay per mole, 1 mole is equals to 6.022 times 10 raised to the power of 23. Ang muna siya, kids, ang imo per helium atom. Kaya again, bisan ano pa na siya, kids, nga compound, ang 1 mole yun na is again 6.022 times 10 raised to the power of 23. And hydrogen commonly exists as a diatomic 2-atom molecules. So 1 mole of your hydrogen is 6.022 man times 10 raised to the power of 23, and your H2 molecules and 6 is equals to 2 times 6.022 times 10 raised to the power of 23. Kaya again, 1 mole of each substance 1 mole of any compound or substance is equal to, bisan ano pa na, bisan hydrogen, oxygen, carbon, or any other element, ang iya 1 mole ginaya kids is always equal to 6.022 times 10 raised to the power of 23. Ang gina ang 1 mole ya, okay? So every kind of atom, molecule, or ion has a definite characteristic mass. It follows 1 mole of a given pure substance also has a definite mass regardless of the source of the sample. This idea is of central importance in many calculations throughout the study of chemistry and the related sciences, because the mole is defined again as the number of atoms in 0.012 kilograms or your 12 grams of carbon 12. And the atomic mass unit is defined as 1 over 12 of the mass of a carbon 12 atom. And the following convenient relationship is true, meaning baliskadon ninyo. The mass, kids, amo niya rule, the mass of 1 mole of atom of a pure element in grams is numerically equal to the atomic weight of that element in AMUs. This is also called your molar mass. Again, your AMUs is also called your, or your moles, is also called your molar mass of the element. Its units are also grams per mole and is also written as grams per mole or G point mole negative 1. So for instance, if you obtain a pure sample of your metallic element of titanium or its formula of Ti, whose atomic weight is 47.88 AMUs and measure, again, ang atomic weight natin, i-provide man sa inyo sa periodic table of elements that I will give you, and measure out 47.88 grams of it, you will have 1 mole, or 6.022 times 10 raised to the power of 23 titanium atoms. The symbol for an element can be used to identify the element, represent one atom of the element, or represent 1 mole of atoms of the element. The last interpretation will be extremely successful, useful in calculations in your next chapter. So again, to document sa inyo kung paano nyo i-solve, and how do we use this. So how do we define the symbols for an element? It can be used to identify the element and symbols of element. Magamit ta para makinalaan ta ang element to represent one atom of the element, meaning your H is equals to one atom of your H. H2 is equals to 2 atoms of your H, so on and so forth. And 3, represent 1 mole of atoms of each of the elements. So H, nga H lang din, is equivalent to 1 mole of your hydrogen. H2 is equivalent to 2 moles of your hydrogen. So those are the 3 ways in which you can use the symbol of an element. So the last interpretation will be extremely useful in calculations in the next chapter. So, but watch out lang. Kagparabalaan yan. The quantity of a substance may be expressed in a variety of ways. For example, consider a dozen of eggs of 55.847 grams or 1 mole of your iron. Again, this is its atomic weight and is also equivalent to 1 mole of your iron. We can express the amount of eggs or iron present in any of the several units. So we can then construct a unit factor to relate an amount of the substance expressed in one kind of unit on the same amount expressed in another unit. So your 12 eggs in unit factors is equivalent to 1 dozen of eggs, and your 12 eggs is also equivalent to 12 ounces of your eggs. Or in unit factors for iron, and the iron naman ari eggs niya. As your 1 mole of your egg is equals to 6.022 times 10 raised to the power of 23 iron atoms. Or your 6.022 times 10 raised to the power of 23 Fe atoms is equals to your atomic mass index units of 55.847 grams of your iron. So as table 2.4 suggests, aring atong table. So here is your table 2.4. So as our table 2.4 suggests, the concept of a mole as applied to atoms is especially useful. It provides a convenient basis for comparing the masses of equal number of atoms of different elements. Ari, table 2.4. For example, ang mass ng inyong carbon or ang iyong mass, kabuguton, or atomic mass unit is equals to 6.022. Again, 1 mole. 1 mole is equivalent to 1 of the constant atomic mass of each element. Again, ang galain ng D is every element, galain ng iyang atomic mass unit pero Fermi equivalent siya sa 1 mole. Okay? So figure 2.9 shows us that next page is on 2.9, ari 2.9. So figures 2.9 show what 1 mole of atoms of each some common elements looks like. So each of the examples in your 2.9 represents 6.022 times 10 raised to the power of 23 atoms of each element. So the relationship between the mass of a sample of an element and the number of moles of atoms in the sample is illustrated in your example 2.3. Which will be shown later. So in this textbook, we usually work problems involving your atomic weight or masses or formula weights or your masses rounded to only one decimal place. Again, so it is only rounded to one decimal place. We round the answer further if initial data do not support the number of significant figures. Again, in situational situations, if they are not supported, the significant figures are rounded off para ma-obtain ta using your rounded atomic weight. Similarly, if the initial data that indicates that more significant figures are justified, we will rework such problem using your atomic weights and formula weights containing values beyond the 10th place. So again, hatagan taman ko mo instruction for every question nga may lain nga round nga pattern for rounding off. So your table 2.4 shows your different elements and their different atomic mass units or their sample with a mass. Kag ang ilang moles contained. So, amo man na siya kids. Makita nyo man sa periodic table of elements. Yun. Ini. And for every one mole ni mo, amo ni ka nga mass depending on each element. So, makita nyo ni kids amo ni nga value sa periodic table of elements. For example, 12.2 grams of your carbon is also equivalent to 6.022 or 2 times 10 raised to the power of 23 of your carbon atom in 1 mole. So on and so forth. So now that we are going for example 2.3, tuanta ka mo paano ni mag-solve. So first kids, look at your example 2.3. We will be solving your moles of atoms. So how many moles of atoms does 136.9 grams of your iron contain? So your iron kids, ang symbol niya is Fe. You are given the mass of 136.9 grams of your iron metal. So first we should write, ariyan na basantang plan. The atomic weight of iron is 55.85 atomic mass units. This tells us that the molar mass of iron is 55.85 grams per mole, or that 1 mole of your iron is 55.85 grams of iron. Again, din ko naman pa, 55.85 grams niya sa iron sa periodic table, okay? Tapos, ang given ta, ng mass niya is 136.9 grams na niya. So, ang pamangkot, pila ka moles ang ara sa aton nga 136.9 grams of your iron. So, we can express this either by of two unit factors. Either 1 mole of your iron atom is equals to 55.85 grams per iron, or 55.85 grams of iron is equals to 1 mole of your Fe atoms. Again, this can be used interchangeably depending on such situations kung sino ang i-cancel natin. Again, pwede mo na gamiton ta kung gusto ta i-cancel si grams of Fe, or pwede mo ni siya aton gamiton kung gusto ta i-cancel ang 1 mole of your Fe atoms depending on such questions. Galing kids, kay ang ginhatag sa aton is 136.9 grams. Therefore, we will use the first expression of your unit factor. So we are given first 136.9 grams of your Fe. So 136.9 of grams of your iron, din ko nakuha ari sa babaw. It is given in the problem. Next, we will find its atomic mass unit. Kaya again, kay cancel ko ni si grams of Fe, therefore ang grams of Fe ko or ang ako na grams of Fe is ara sa dalom and my moles are ara sa babaw. So for every 1 mole, kaya ginapangitak ta moles of atoms naton. For every 1 mole of our iron atom, I will have 55.85 grams of your iron. 55.85 grams of your iron. So kids, before we solve this, we should cancel out all like signs. Cancel ang grams of your iron. Cancel. Ano bilinta? You have your 136, your 55, and your 1 mole of Fe atoms. Alright, and lastly, solve. Again, ang tanan nga ara sa babaw, kids, you multiply, and tanan nga ara sa dalom, i-divide. So, according to our MDAS law, unahon ta si multiplication. So, 136.9 times 1 mole is still 136.9. Divided by 55.85 grams of your Fe, you are left with 2.451 mole. Ano bilinta nga unit? Mole of your iron atoms. Therefore, you should write mole. Ayun, kalain na dito. Mole of your iron atoms. And this will be your final answer. So next, we have solved your moles of atoms. What if we are finding naman number of atoms, hindi moles? Again, kay napangita ta kaginay si mole subong si number of atoms naman. Well, first, we should read the question. Your number of atoms. So how many atoms are contained in 2.451 mole of your iron? So 1 mole of your iron of your atoms of an element contains your Avogadro's per mole niya. Per mole naton, it has a constant number of your Avogadro's number of 6.022 times 10 raised to the power of 23. So we are finding the number of your atoms. We should use the moles of your atoms in order to find them. Kaya again, ang siya ang given. You are given 2.451 mole of your iron. So we may now use this solution interchangeably. Depende kung sino gusto ta i-cancel out. So we are given mole of your iron. So dindi ang aton nga pangitaon. Ang aton na gamiton. We should use the first expression. Ang first, aring second. So we should use the first expression kay i-cancel out ta ang moles of atoms ta to find your number of atoms. So again, we are given 2.451 mole of your Fe atoms. Next, as we are given your 2.451 moles of atoms, we should write your first expression na kay gusto ta i-cancel si mole of Fe atoms naton as we are finding your number of atoms. Okay? So we should now put our moles next. So for every 1 mole naton, kids, may ara ta gani ano, according to our Avogadro's number, we have 6.022 times 10 raised to the power of 23. Again, this is your scientific notation, okay? 23, ano aking unit diri? your Fe atoms. Okay, again, for every 1 mole may ara asang amuni nga 6.022 Fe atoms. Fe atoms. Anyhow, next, as we are given 6.022 times 10 raised to the power of 23 of your iron atoms, it is also always equivalent to 1 ano ganit. It's a 1 mole of your Fe atom. 1 mole of your Fe atom. Depending on your element given in the question, islan mo lang siya. So you are given iron. So your Fe is your iron. Fe ang symbols ng inyong iron. Okay? Fe atoms. So do we have any like signs? Yes, we have the like signs of here. Cancel all like signs. Multiply tanan sa babaw and divide tanan sa dalom. 2.451 times 6.022 times 10 raised to the power of 23 is equals to 1.476. Divided by 1 is always 1.476 times 10 raised to the power of 24. Check nyo sa calculators nyo as this is the answer. So ano bilinta nga sign? Kinakancel ang duwa sa babaw kang sa dalom. We are left with your Fe atom. So this is the number of your iron atoms. So this is how you solve your atoms, number of atoms. Easy lang, di ba? So next, we'll discuss your Avogadro's number. So your Avogadro's number, if you think that the value of your Avogadro's number is 6 times 10 raised to the power of 23, is too large to be useful to anyone but a chemist, look up into the sky on a clear night. You may also be able to see about 3,000 stars with the naked eye, but the total number of stars swirling around you in the known universe is approximately equal to Avogadro's number. Just think of the known universe contains approximately 1 mole of a star. So again, ang every molecule na is always equivalent to 1 mole. So kung may star kita, every star natin is equivalent to 1 mole of your stars. You don't have to leave the Earth to encounter such large numbers as 6.022 times 10 raised to the power of 23. So the water in the Pacific Ocean has a volume of about 6 times 10 raised to the power of 23 ml in the mass of 6 times 10 raised to the power of 23. So Avogadro's number is almost incomprehensibly large depending on what molecule we are using. For example, if one molecule of the dollar is given away at the rate of a million per second in the beginning when the Earth was first formed, some 4.5 billion years ago, would any remain today? Surprisingly, about 3 to 4ths of the original mole of your dollars, meaning 3/4 billion pa, would be left today. It would take about 14 billion and 500 million years more years to give away the remaining 1 million per second. So computers can be used to provide another illustration of the magnitude of your Avogadro's number. If a computer can count up to 1 million billion in 1 second, it would take the computer about 20 million years to count up the 6 times 10 raised to the 23 of each mole. In contrast, recorded human history goes back to only a few thousand years. So the impressively large size of your Avogadro's number can give us a very important insight into very small sizes of individual molecules. Suppose that one drop of your water evaporates in 1 hour. So kids, ang essence man lang ni sa aton Avogadro's number is that it is big ang for every molecule that a substance has. Amo lang gid para hindi na ako magdubugol. For every molecule that one substance has, for example, one molecule of your water, it is always equal to 6 times 10 raised to the power of 23. Or in essence, kag ginagamit ito sa solvings, for every one molecule, you have 6.022. As we are using 6.022 times 10 raised to the power of 23 for every molecule that the substance has. For every one molecule, meron ka na number. Because this number is very long. Sobra pa nisa sa trillion. Ano mo na iyawan ka padula sa molecule of each substance. So next, we have your masses of atoms in example 2.5. So calculate the average mass na naman, kids. Average meaning we are dividing through your average. Calculate the average mass of one iron atom in grams. So you are given nothing except your iron atom in grams. So we expect that the mass of a single atom in grams would be a very small number. We know that 1 mole of your iron atom has a mass of 55.85 grams and contains 6.022 times 10 raised to the power of 23 of your iron atom. We use this information to generate unit factors to carry out the desired conversion. So kids, we are given nothing but your iron. So we should use that iron in order to get the masses of your atoms because we are finding its mass on its average mass per one iron nga atom. We are given first your iron atom. What is its grams? Therefore, we should put your question mark as we are not given its grams. Just your atom. Next, for every unknown of your grams of your iron, we have your Fe atom. So kids, din tani pangitaon ang inyong grams. Again, it is your atomic mass unit. Because your mass is equals to your grams. It is 55.85. Ganun ko yung kwa sa atomic mass, sa inyong periodic table. 55.85 grams of your Fe. For every 1 AMU natin, may ano tagan kids, may 1 mole of your Fe atom. Again, to get your average mass, we are using the ginagamit natin kids. So, the number of atoms natin nga solving and your moles of atoms meaning ini yung gamit natin kag ini yung gamit na natin. So, look at your formula and your average. Okay? So, first, ginbutang natin ang aton na AMU or your atomic mass units. Next. So, for every 1 mole natin sa Fe atoms, kids, kaya we are finding your mass. Ngayon natin gani, for every 1 mole natin of your iron atom, we have an equivalent Avogadro's number of 6.022 times 10 raised to 23. 6.022 times 10 raised to the power of 23 Fe atoms. Atoms niya. And we simply solve your problem. So kids, multiply tatanan nga sa aras babaw. First kid multiplication before division na M-DAS law naton. And tanan nga sa dalom i-divide naton. So cancel all like signs. Again, cancel all like signs. So may grams of iron ko? Yes, ara. And sila. Wala ko kids ang grams of your Fe atom. Again, may ara ko kids moles of Fe atoms? Yes, may ara ko. Ara moles of Fe atoms. Next, may kaparigo pa ko nga symbol. Wala na. Bilin ko na lang is your 55.85 grams of Fe atom nga wala sa kaparigo and your Fe atom lang gid. Hindi siya grams, meaning it is your Avogadro's number. So, you now have the average of multiply tatanan nga sa babaw, divide tatanan nga sa dalong 55 divided by 6.022 times 10 raised to the power of negative 10 of 23 gali. Hindi siya negative pa. You now have the answer of 9.274 or simply 9.27 times 10 raised to the power of negative 23. Again, nag-divide ta, wala ta nag-multiply ha. Umuna nga, nag-negative siya. Kaya mas nubo ang number nga ara sa babaw kaysa kahit talog, di ba? Mas dako si 6.022 times 10 raised to the power of 23. Kaya again, trillions, sobra pa sa trillions ni ang ato na Avogadro's number. Ano bilin ta nga? Signs. Again, copy lang ang tanan yung signs ka na bilin. Grams of your Fe over your Fe atoms. So this will now be your final answer. And next, paano naman if we are using your Avogadro's number? Last na lang kids, don't you worry. So a stack of 500 sheets of typing paper is 1.9 inches thick. Calculate the thickness in inches and in miles of a stack of typing paper that contains 1 mole of your Avogadro's number of sheets. So again, we are using your Avogadro's number to calculate the thickness in inches and in miles of a typing paper as 1 mole is of each sheet of paper. So meaning, simply, i-divide na lang ang ato na Avogadro's number to your 500 sheets and multiply it by 1.9. Again, multiply, divide. Amalagin siya kasi simple kids. So we are given 500 sheets and its thickness of 1.9 inches. So muna ni Ibrahim kids to find your moles. We are given 500 sheets and 1.9 inches thick. It is equivalent to 1 mole of your sheets. Don't worry kids, hindi ko na siya pagwa kay feeling ko malibugon ninyo, pero example lang takong para kabalo lang dit ka mo and for you to know. So 1 mole of our sheet per sheet ni naton is equals to 6.022 times 10 raised to 23. Again, kay constant na for every 1 mole of each substance, may ara ka 6.0.22. Galing kay sheets ni sa, this is how we solve for your Avogadro's number. It is always equal to 1 mole of your substance, and in this case, your sheets. And then you multiply it by its given thickness of 1.9 inches. So for sa 1.9 inches na siya kuno ang kadakbulon sang aton 500 sheets of paper. Therefore, butang tang 500 sheets sa dalong, di ba? Next, multiply ta tanan nga ara sa babaw and ang tanan nga ara sa dalong, i-divide. Cancel all like signs. Cancel ang sheets de, cancel di ang atom nga mole of your sheets. And you have your 1 mole de, cancel, cancel. Finally, we have your 2.3 inches. Inches lang bilhin natin. And multiply this by 1.9 before we divide it by 500. Times 10 raised to the power of 21 inches. So we have calculated its thickness na in inches. Now we convert this 2.3 times 10 raised to the power of 21 inches into miles. Kaya again, we are now finding, kinakita ta na sa inches, si miles na naman ta, convert to siya kuno into miles. So we are now finding your miles. Sulatan na natin sabat nga in inches. First answer tani 2.3 times 10 raised to the power of 21. So for every 1 feet na akong kids, may ano ko gani may 12 inches. Amo na siya ang iya English metric, am I right? 12 inches. IN. IN yun eh. Next, we multiply it by 1 mile as we are converting it into miles. So for every 1 mile na to, may ano to gani kids, we have 5,280 feet. 5,280. Again, cancel all like signs. May inches ko, di ba? Right. Therefore, cancel your inches, cancel your feet, and you are left with your miles. Now, you have the final answer of 3.6 times 10 raised to the power of 16. This is your miles. So this will be your final answer in your miles, and this is in your inches, and that is how we measure your Avogadro's number in certain meter nga mga measurements. So your Avogadro's number in simple terms is used in many different areas, whether it's physics or chemistry or any other field. Gamiton gid sa Avogadro's number naton in many ways to solve for your moles of atoms, measurements, and other kinds. So that will be all for today, and thank you for your time, kids.